So please see that you will be able to see my screen. Are you able to see my screen? Hello, anyone?
No, sir.
You're not able to see screen?
No, sir.
No, sir.
Let me check. Okay. I hope it is visible now.
Yes, sir.
Yes, sir.
Do you remember we were here till internet sites yesterday, last time? Is it okay now? Okay, should we start? Okay, so we'll start. Last time we have seen from where we can collect information about materials. We have seen that there are textbooks, there are uh, design data books, there are manufacturing catalogs or manufacturers information or brochures are there, and internet is there. So there are variety of sources from which you can get information. Let us go ahead now. If you have to choose the right material for your product, then two important things are there, that performance of the product and cost. Because if you want to sell this product into market, or if you want to use it for any other application, performance is important, that the product is designed for specific purpose. So it has to serve that purpose. So it should perform as per our expectations. Second thing, cost is also important. Your product is very fantastic, but cost is very high. Then many times the product may not be accepted. So you must be able to focus on these two parameters. One is performance, another is the cost. Now, while choosing material, if these two things are taken together, then this makes a lot of difference. For example, suppose you are taking example of any fighter plane, then it is very difficult to manage performance and cost hand in hand. But this is very essential that your product must perform in a best possible way. At the same time, cost should be affordable. So you should be able to see this bigger picture. Third important thing is you also should be able to think of manufacturing. Product is very fantastic, design is very good, it will perform well, but will you able to manufacture it? Whether material is available, can you process that material to a desired shape, geometry, and whether this material is easily available to make it. So manufacturing process has to think while designing a product. So first is performance, second is cost, and third is also manufacturing, which is equally important. Now we'll take example of a bicycle or bike. Then bike do have a are made up of variety of what you can say sub assemblies together. It comes with frame, forks, wheels, pedal is there, you have a chain drive is there, seat is there, then handle is there, brakes are there. So many things are there, and by making or joining these parts together, you are making a bicycle. Now let us see what is exactly requirement of the bicycle. Bicycle do have a certain requirements like mechanical, means it should be able to take one or two persons, depends upon bicycle design. It should have a capacity to run maybe 20 kilometer per hour or 40 kilometer per hour speed. It should sustain enough strength for bad roads or dirt, dust. You should use wheels in such a fashion that it will be able to maintain grip on the road. So these are mechanical requirements. There are certain ergonomic requirements also. Means when a person who is driving bicycle, he should be able to ride on the bicycle. He should be able to ride on the seat. So seat height is important. Seat shape is important. Seat material and its geometry is also important. Seat to pedal distance is important. When you are sitting on the bicycle, you should be able to reach to the ground by your feet, maintain your stability or safety. That is also important. So many ergonomic requirements are there. For example, you are sitting on the seat, but you are not able to reach to handle. Then you will not be able to drive bicycle. So these dimensions, shapes, or configuration is important for from ergonomic point of view. Third thing is aesthetics. Your bicycle or bike must look good. It should be attractive. It should be light in weight. The parts, its color, look, it should be very attractive that you will love your bicycle. So these are the requirements. Bicycle do have a certain functions, like it has to attain certain speed. It should be able to have or able to run on good or bad, whatever kind of roads. You are expecting some speed also. You expect comfort. You also expect safety. Now these are certain requirements and functions. Now these functions and requirements, if you club together, then it comes that which material you will choose. Let us go to the bicycle frame. The image you see is a bicycle frame. Now this frame is made up of, can you imagine what material might have been used for this frame? Mostly all bike frames are made up of metal, and preferably it will be a steel, or in high performance bikes or bicycles, they use aluminum alloy, which is light in weight, providing high corrosion resistance, very good strength. So those are some benefits. If you see the frame only doesn't mean for or designed for providing a framework for bicycle wheels, but aesthetically it should look like good. It will have certain matter printed on it that creates a brand of bicycle. So many aesthetic things are there in the bicycle. Now, while selecting material, you must know the requirements, functions, aesthetic requirements, ergonomic requirements, how it will look like. So on the basis of that, you can choose first material as a steel, which is very high strength, enough stiffness, which is heavy, and also it is cheap. So steel can be your first priority. Second can be aluminum. Aluminum has certain characteristics like it is expensive, light in weight, but comparatively weaker than steel. Now, you can choose aluminum where your frame cost, if it increase, then it is acceptable to you. If cost is your criteria, then definitely you have to go for steel. If light in weight and performance should be your criteria, then you have to go for aluminum. Other option can be, can you make bicycle frame from composite? Composite is either fiber reinforced plastic or carbon fiber reinforced plastic. You can have an option that reinforced plastic can use carbon reinforcement, which will increase strength of the bicycle frame, provides very ultra light in weight, and also it do not have any what I can say environmental effect or corrosion effect. It is anti-corrosion. So composites are very strong, provide good strength. As compared to aluminum, also it is light in weight, but it is very expensive. And also making of composite frames is difficult. Now, if you remember, earlier we discussed about while selecting material that you must think about requirements. So requirements should be fulfilled. It must have sufficient cost or desired cost or required cost. And third thing, what we think about manufacturing. Now the issue of manufacturing arises here for composites. You can make composite, you can select composite material for bicycle frames, but will you be able to manufacture it so complicated shape? Because bicycle frame is made up of tubular shape. Is it possible to make composite or use composite for bicycle frames in tubular cross section? And if it is there, whether it is having desired cost band to manufacture or to fabricate, this we have to think. So likewise, material selection should be made. I had given another image which speaks about how complicated shape is there to make frame by means of fiber reinforced plastic. A front joint where steering column of front wheel is connected and handlebar is connected. This portion is very complex, and in addition to that, it requires very high strength, because if this fails, the driver may fall on head and it may cause severe head injury. Now, these parts are very intricate, complicated, and you should be able to make it. So, while selecting material, you must think that can you make such complex areas of frame where this can be used. For example, another case study we can take for containers. A drink container. You might have seen Coca-Cola or Coke containers, thumbs up containers, or soft drink containers, which is used to carry, store, handle soft drinks. Now, what is the requirement of this container? Requirement is something like this. It must provide leak-free storage of the liquid. It must comply food standards, protect liquid from health hazards, direct sunlight, contamination, because it is food element or it have a food value. So whenever you want to preserve it, it should comply with food standards and it should not create any hazard. It must withstand the pressure, because many times all these soft drinks are filled under pressure. So they should withstand this pressure. It must create brand and identity, that whenever you see that content, you should be able to recognize, yes, it is Coke or it is Sprite or it is something Mirinda or Mazda, something like that. So it is creating brand image also. That is what about aesthetics. It must be easy to open. Here ergonomics comes, because if you see the container cap, it should be easily opened, and at the same time it should provide desired sealing level also. So it should be easy to open. Containers must be easy to store and transport, that one over another container can be loaded, packed, and it should be easy to transfer. So these are certain requirements, and cost and obviously other things are there. So you have to think about the cost, and on the basis of that, you select material for the container. If you go back and see the container, then containers looks like this. The shape, color of the container, its geometry, in its what I can say opening provided, all those makes a lot of sense. And even this is a single use type of product. It is not reused. Later it go for recycling. This is not a reusable. So you have to think about the cost also. How much you will invest into that product which is going to be single use. So all these factors are required to be considered. So I given two examples by which you will understand what are the issues in selecting materials. Let us go into some more details about the material. So materials can be divided into two major characteristics. One are the hybrid materials, another is the monolithic materials. In monolithic materials, you find metals and their alloys, ceramics and glasses, polymers and elastomers fall into one kind of category, which is monolithic material. You can have a hybrid materials in which you can have composites, sandwich materials, lattice, or you can have segment. Here, composite means you have two or more materials together. They are arranged in such a fashion that it will make a matrix in such a fashion that it will provide desirable strength. Aircraft parts are mainly with composite materials. The reason is they must have a lighting weight capacity, and at the same time they should have to have very high strength. If you compare metals with composites, then metals are having high strength as compared to composite, but their density is very high. So their weight is much higher than composites. If you compare composites, it is much beneficial than metals because they are light, having low density, and they can provide strength at par with metals, or sometimes they provide higher strength than the metals. Second is sandwich. You can make two, three materials together, layer by layer, and you can form a sandwich material. This also having certain benefit that surface can be made of metals An inner part can be made of soft material or rubber, plastic, or any other wood also, and that can give you a sandwich. Your plywood, laminated plyboards are example of a sandwich. Then lattice. Lattice is nothing but typically a combination of material and space. Means hexagonal part in gray color shows that there is a material, and in between these material there is a cavity which is shown in white color, that is the air cavity where no material is there. This provides good strength and at the same time it reduces weight of the material. So this can be done like this. Next is segment. Segmented structures are made up of some laminated layers, one over other, a combination of one, two, three, four materials. So that is what the segmented. Your plywoods are made up of like this, which you have layer by layer bonded together, pasted together, and that makes a one-piece board, which is called as a plywood. So normally hybrids are designed for giving high strength as compared to monolithic materials and maintain good, what I can say, strain to weight ratio. This is property of the material. Let us try to understand some of the terminologies which are related to the material. First terminology is nothing but stress. Three terms which are important while defining capacity of the material: stress, another is strength, and third is the modulus of elasticity. Now, what is exactly stress? Stress is nothing but load divided by area. Here, FA stands for a normal force acting area, and A stands for area. So, stress is load divided by area. Indirectly, this defines capacity of material to sustain specific load for unit area. If you bring this A to the stress side, then load becomes stress into area. Means load carrying capacity of the elements depends upon its stress. So this defines the capacity of the material to carry load. Second term is strain. Strain is nothing but change in length divided by initial length. Whenever you apply a load, then under the application of load, here load means a tensile load. Tensile means you are pulling, suppose you have taken a rod in your hand and you are subjected to pull. Now what happens when you pull it? If it is made of elastic material, then you can see that it will get elongated. Its length will increase. Now there is an initial length L0, and after application of the force, there will be change in length. So if initial length is 1 meter, then it becomes 1.2 meters, suppose. Then L is 1 and delta L is 0.2 meters. This ratio of change in length divided by initial length is nothing but the strength. Now strain comes into picture when you apply tensile force, means you are pulling a rod, and stress is nothing but when you put some compressive loads, means you are putting load on the material that will tend to compress it. Now stress and strain are the two properties which define material elasticity or material qualities. On the basis of stress and strain, third important parameter comes into the picture is Young's modulus. Young's modulus is ratio of stress to the strain. We have defined that stress is equal to load divided by area, and also we have defined as strain is equal to change in length divided by original length. The ratio of stress to strain defines Young's modulus. This is very important characteristics of the material which defines deformation in the material and the load carrying capacity of the material. Now, this by using this property, you can use this chart which is now shown. This chart is material density versus Young's modulus. Now, material density, you know, density is defined in terms of kg per meter cube, and we have defined now Young's modulus in Pascal or gigapascal, which defines stiffness. Now, when you say that Young's modulus increases, then material stiffness go on increasing. If you see an axis where Young modulus is there, you'll see that if Young modulus increases, stiffness of the material increases. And as Young modulus decreases, it becomes flexible. Now you see density side, then at density, if density of the material increases, material becomes heavy or its weight go on increasing. And when density reduces, the material becomes light in weight. Now, if all those monolithic and composite materials have been put onto this graph, then you will identify that different materials fit at the different level in this graph. Now, this graph will help you to select appropriate material. How this selection can be done? Now, for selecting a material for any typical component, you have to know requirements of the material. Now, when you know requirements of the material, you will came to know that material have certain requirements. Now, these requirements, you can check it over here. Just 1 minute. You can check it over here. Sometimes you, for example, if you want to select a material for aircraft, then it should be light in weight, but at the same time, it should have very high strength. Means they must have very high stiffness or good stiffness, but they should be light in weight. Suppose you want to use material for your sofa set, then they should be light in weight and they should be flexible, soft. If you want to select material for your bicycle seat, then material should be soft at the same time they should have good strength. Then, if you divide this figure into 4 quadrants, the quadrants are like this. The extreme right bottom quadrant will be flexible and light. Then right bottom quadrant will be heavy but flexible. If you go to top left side quadrant, then you will find material is stiff and light in weight. And if top right quadrant, if you refer, then you will find heavy and stiff material. Now, whether you need flexible, light material, whether you need flexible, heavy material, whether you need light, stiff material, or whether you need stiff and heavy material. Now, on the basis of your requirement, you have to select the material. For example, if you have to use flexible and light material, then you have an option to select foam. If you have in between stiffness, means it should not be so flexible, it should not be very high stiff. Intermediate stiffness is required and material should be lightweight, then you can have wood and wood products which are shown in the green color. If you want somewhere mid density and mid of the stiffness, means somehow stiffness and somehow intermediate weight, then you can select polymers because they have a, not exactly light in weight, but they have lower weight and providing better strength also. You can have composites which increases stiffness, but density remains very similar to polymer. You can have ceramic materials which you can go for very high stiffness, at the same time their density is also high. And metals falls into right top quadrant. They are having very high stiffness, at the same time they are very heavy. So this is how, depends upon requirement, you can select material. I hope you might have understood this chart, which you can use it for selecting of the best material. So how to select a material? Then the use of this material selection can visualize the properties. You can show different materials and their categories. You can make balance of strength, cost, and stiffness or light in weight combination of this chart. So you can use this chart in such a fashion that it can be best suitable material for you. So you have to follow these steps. First step is think about design from ergonomic and functional viewpoint. What is your functional requirement? What is your ergonomic requirement? I hope ergonomics word you have understood. Ergonomics is science which deals with interface of man and machine. That is what ergonomics. Then you must think about function and ergonomics together because all products are used by human beings. So ergonomics comes into picture. Then go for deciding the material which can be used and select suitable process which can be used to manufacture these materials. You can have a number of iterations to, if you have a multiple materials in your choice, then you can carry out multiple iterations for step number 2 and 3 in such a fashion that you can evaluate materials for best possible level. Now we'll take certain examples and with the example we'll try to understand how this can be done. Suppose you have to manufacture a material which is a lens for automotive tail light. Which material can you use? This do have a certain specific properties. It should be light in weight. It should have good transparency. It should be able to make complicated shapes. It should not have any environmental effect. There should not be any what I can say marks of erosion, dust, dirt particles when they collide with the glass. All those characteristics, if you see, then acrylic will be the best material for this. Another is wood or wood. Wood can be casted to any intricate shape. This is a model which is made of a balsa wood, which is made by an architect to show how a temple will look like. If you have to cast into intricate shape, complex geometries, and good workability, because wood have very good workability, that's why wood is used for furniture items. If you see your chair, sofa set, or wooden furniture used in house, that can be made into a typical complex shapes to make desired geometry shape for aesthetic point of view. So wood can be the best material for this. Next example can be your CD-ROMs or CD drives, which is normally made of polycarbonate. So this is the best material for that. You have to make suppose tools for metal cutting. You have to have very high strength. Now for high strength, you have to go for tungsten carbide tool bits, which will have very high wear resistance and good strength also. Bicycle example we have taken just now. If you have to make suppose ceiling or a false ceiling in a complex shape, then you can use cotton, linen, nylon, or somewhat say biomaterials which can make this. So there are large variety of materials. We'll start with plastic. Plastic can be classified as thermoplastic and elastomers. So plastic there are basically three categories: thermoplastic, thermoset, and elastomers. Under this, you can have acrylic, nylons, PVCs, polyethylene. Under thermoset, you have resins, phenolic resins, polyesters. And under elastomer category, you have rubbers, silicones, or polyurethanes. Plastic has shown a very, what I can say, excellent position in replacing metals and woods because plastic do have a certain very beneficial properties. Plastic can be made in a complex shape. Plastic do have very light in weight as compared to any other material. Plastic also provides sufficient strength. It is eco-friendly. It do not have any environmental effect. Handling, storing is also very easy. Manufacturing is also very easy. So by virtue of this plastic, there are certain benefits. But this may lead to have certain what I can say limitations that recycling of plastic becomes difficult. I'm getting message today that the meeting will be short of time, so it will be end. If it end, I will restart the meeting and we'll continue for next 10 minutes. Then there are certain parts which can be made like this. You might have seen a containers, many containers which is made of plastic. Now, this is the best possible application of plastic. Easy to store, light in weight, low in cost, easy to manufacture, easy to paint, easy to give intricate shape. So plastic is the best material for certain components like this. It will have certain benefits also. You can see the compounds which is made by plastic. You can see here a plastic gutter which is used to collect rainwater. In such complex shapes, and it also can be made in light in weight. Plastic can be the best material for such type of application. You can see a material handles which are used for cooking utensils, wherein the plastic will serve the best performance because it will have a high thermal resistivity. So it is bad conductor of heat, especially a bakelite, which is used to make handles of kitchen utensils, do have a good strength at the same time light in weight. And another important property is it is heat resistant. It will not transfer heat to the human organs. These are some other application of the plastic where plastic serves the best because it is bad conductor of electricity. So all electrical switches, electrical appliance bodies are made up of plastic. It's another application of plastic. Then elastomers, which is nothing but rubber. The most and commonly used example of rubber is tire. Entire automotive industry transportation is based on tires, and tires are made up of rubber. You can see shoes. So shoe bottoms are made up of elastomers, wherein you can provide good softness, which will not carry damage to human feet. It can be casted to complex shape to suit your feet profile. So these are the benefits of elastomers. Then we go to the wood category. Wood will have basically three, four types. One is softwood, another is hardwood, and third is the combination of variety of woods together. That is what called as boards. Hardwoods are oak, ash, beech, and sycamore are the hardwoods. You have a softwoods like pine, cedar, fir, or spruce are some of the examples of softwoods. We in India prefer teak wood, which is the best possible wood, which replaces oak, which is used in Europe and America. Oak is not commonly available in India. We have available teak, which is very commonly wood. It is having good or can strength at the same time. It is very soft to work. So it is combination between a hardwood and softwood. There are certain wooden materials which is made up of combination of wood layers. That is plywood. Here you use blackboard, MDF. You might have seen that MDF is normally used for kitchen tops or cabinets, kitchen cabinets, kitchen trolley covers. So that is what MDF. There is also melamine board, which is coated board, which are used to what I can say prevent erosion and wear of the wood surfaces. So there are large variety of woods which are available. You can have wooden planks which can be made into complex shapes. They have a good grain values, provides enough strength. They are aesthetically good. They can be made composite like laminated board. So wood do have a certain what I can say benefits. Here I have shown an image which shows you a plywood which is made up of layers of the wood particles. So this will suit your requirement. Next is composite. Composite do have a certain benefits. First, the benefit of composite material is nothing but its strength. So two are different materials. When they combine together, it become a composite. And they are bound together either by means of a chemical bond or metal bond. Because of their high stiffness, high strength, they are widely used in aerospace, offshore structures, boats which are required to be light in weight, sports materials. So this is the benefit of using composite materials. You can see application of composite materials like this. Windmill blades, windmill towers are also made up of composite materials. Then boats, they are light in weight and they have less environmental effect or salt water effect. So composites are best suitable for this. You can see here a racket which is used for tennis. So tennis racket is required to be light in weight but very high strength. That is also made up of composite material. So composite can be either reinforced plastic, it can be ceramic, it can be metal composite, laminates. So these are certain examples where two or three different materials are bonded together by a chemical or adhesive bond and a material is made up of composite. There are certain other examples which you can see here that metal matrix which are used for combustion chambers for a jet engine which require not only high strength but at the same time it require very high temperature resistance also. Now this will demand a specific material which can work at very high temperature. So ceramic materials may provide very high strength. You can see an automobile car which is combination of variety of material. You find here sheet metal, either steel sheets or aluminum sheets. You'll find here casted parts, you find here glass, you find here wool, you find here home, you will find so many variety of materials which are used to build a car, to make a car as a wonderful piece. You can see an engine which is subjected to very high temperature, that is made of metals, but metals are require some certain treatment that they can withstand this high temperature. So there are many applications of the material. So next category of material is ceramics. Ceramics are bitter materials. They are non-metallic, but they do have very high capacity to withstand temperatures. So there are tools made up of carbide or nitride, which is used for as a cutting tools. There are certain ceramics which are used to make components which are required to withstand very high temperature. Your spark plug is one of the example of component where it is combination of ceramic and metal together, which will withstand very high voltage, indirectly very high temperature inside the combustion chamber. So this is what the application of ceramics. You can see now a cutting wheel or abrasive cutting wheel, which is made of also ceramic for polishing and cutting purpose. Let us go on to the metals. Metals are of two type of metals. One is ferrous metals, another is non-ferrous metals. In ferrous metals, you will find steel, stainless steel, high-speed steel, cast iron, and in non-ferrous you will find aluminum, copper, brass, titanium. These are the materials which falls into non-ferrous category. Metals can be used to create shapes like I am showing now. It can be made into tubes, sheets can be made, complex geometries can be made. Metal can be casted to complex parts. Metals can be cut into given shapes like you are seeing now, nuts, bolts, rods, elements. Metals can be made like this, which can be used as a tools. Metals can be casted by a sheet metal, like a sink, which you can see it is made of stainless steel. So these metals are most suitable and very widely used in the application. Now the last material is fabric. You know, fabrics which are used for clothing purpose, it is used for upholstery, used for curtains, used for shade, temporary shade, tents. So there is a lot of applications of fabrics. So fabrics can be made up of either from natural material like cotton or canvas, or it can be a synthetic material like nylon or polyester. Natural materials are comparatively costly as compared to synthetic and nylon materials, but synthetic and nylon materials also provides a good properties also. So it depends upon your application, you have to choose appropriate material. Now here we have completed almost all metals.